All right, let's look over this problem that I've had you working on. So we took example 2, part 2, and we completed the square to get our equation in standard form. So now we want to figure out the vertex. So the vertex will be at -1/2, comma 6 1/4, or 25/4. Yes. And then what does the negative out in the front of our, it means it's upside down. Yeah. Reflected over the axis. All right, so I'm going to go left 1/2 and up 6 1/4. My graph paper is kind of too small to really make that. Oh, that's just a straight shot. Okay. So 1, 2, 3, 4, 5, 6 and a 4th-ish, somewhere in there. And then the problem is going to keep going upside down. So there's just an approximate what our graph will look like. Okay, at this point we know enough that we can do the axis of symmetry, which is just going to be x equals -1/2. And we can go ahead and do the range. So this time our parabola has a maximum value instead of a minimum value. So how are we going to list the range? -infinity, and then it goes up to 6 1/4, right? Or 25/4, whichever. And it includes that point, so we want to make sure that that's a bracket. Okay, so we've got our vertex, we've got our basic graph, we've got our axis of symmetry, we've got our range, and then the domain is all the numbers. So next we need to find our x and y intercepts. So for x-intercepts, let's take our function. The negative kind of makes things harder to factor. So even though I'm not actually completing the square this time, I am going to go ahead and take that negative out again. Just get that negative out of there. So then when we go to find the x-intercepts, this side will be 0. And do we even need the negative when the other side is 0, or can we just work with it as being positive? Like, think of it as multiplying both sides by a negative. A -1. That's fine if we multiply both sides by a -1 and just completely ignore the negative. Does that make sense? So let's go ahead and factor this. So imagine that we did this little multiply both sides by -1 and we just get rid of that negative. Okay, so now we're just going to factor. What are the factors of x squared plus x minus 6? Perfect. So x times x is x squared, right? And then -6 could be -6 and +1, or +6 and -1, or -3 and +2. Or +3 and -2. We want that +1 in the middle. So we're going to do +3 and -2 because those numbers multiply to get -6 and they add up to 1x. So now we can take each of those factors, set it equal to 0. And we have two x-intercepts, one at -3 and one at 2, which means I didn't really do a great job of graphing this, and maybe I should have waited to graph it until I have those points. So there's a point at -3 and a point at +2. I was like graphing it as though it was skinny, like stretched. It's not really, it's just flipped upside down. It's not like stretched vertically. But. Okay, so then the last thing we need to do is find the y-intercept, and that's always super easy because you just go from the original problem and look at the constants. Because what happens if you put that 0 in for all of those x's? 0x squared, 0x, all that's left is what? plug 0 and 12 the x's into our original problem. Yeah, just that constant is 6. So our y-intercept is going to be right here at 0, 6. So that just comes from plugging in at 0, and all that's left is 6. Our x-intercepts are at -3 and +2, because those were the factors we got. The important thing here is to understand the importance of both general form and standard form. Do you see how they both play an important part in these problems and graphing and understanding them? So it's really powerful to know both of those. Okay, so I know we're almost out of time. Not sure what's on my next screen. Okay, it's just another problem to practice. I thought I had somewhere approved. What I'm going to point out to you here is that instead of having to complete the square, so remember every time we completed the square, we halved the number next to x and then we squared, right? And the number we got when we halved it was the number that went in our parentheses, and that moved it left or right. So there's actually a little formula to help you find that. So instead of completing the square, like I said, if you're not really comfortable completing the square right now, you'll need to be in chapter 5. But right now, you can just use the formula x equals -b over 2a. B is the number next to x, and 2 has to do with halving to complete the square, and a has to do with the fact that if there was a number in front of x squared, like that coefficient like we had on the complicated movie encryption problem earlier today, we had that number in front we had to factor out. So do you remember in my inverse problem, we had to divide everything by 6 because we had that 6 coefficient there? That's the idea behind this. So this formula comes right from completing the square. It just makes it a shortcut so that you can bypass the completing the square part just to find x. But then you have to plug it in to find y. So maybe if you'll be patient with me here, we can actually go through this problem with the formula instead of completing the square. Does that sound good? So we're going to use x equals -b over 2a to find h, and then find. And then we plug in h. So remember, the vertex is a point on the graph, x, y, we just call it hk, that tells us where that vertex has moved left to right and then up or down. So once we find h, if we plug it into the original problem and get the y value, that is k. So instead of completing the square, we're going to do this. Sound good? So we have f of x equals, oh, well, it's right there, I'm not going to rewrite it. My bad. Okay, we're going to do x equals -4 over 2 times 1. What did I just do? I used my little formula, -b over 2a. So b is the number next to x, which is 4. So -4 over 2a. So 2 times a, which was 1. So 2 times 1. Divide that out, and I get a -2. And the reason the negative is in there is that's to remind us that it goes the opposite direction. Okay, so now we plug that into our equation. We're going to go f of -2, and that will give us k. So we're going to plug in -2 squared plus 4 times -2 plus 7. And we get 4 minus 8 plus 7, which is -4 plus 7, which is 3. Right? Is that what you guys got? Plug it in. So where's our vertex? There's the vertex. Now look at our original function. Is it going to be reflected upside down? There's no negative in here, right? So now we have the vertex, we know it points upward, there's no stretch. Now what do we do to find the x and y intercepts? Set it equal to 0, factor it, find the zeros. Then to find the y-intercept, we just look at the constant. What's the constant? 7. So the y-intercept is 7. And then you just finish the instructions. So you've got it, right? One thing though is on your assignment, it's going to ask you to convert the function from general form to standard form. If I didn't complete the square to do that, how can I use what I know about where the vertex is? How can I rewrite this in standard form without completing the square? What would that look like? So it's going to move left 2. What's that going to look like in my equation? Yep, x plus 2. And this is a parabola, so we have to have square. That gives us the shape. And then we have our 3 for k, so that's going to have our plus gradient. So there's its standard form just by finding the vertex by doing -0 over 2a instead of the completing square. Okay, you guys could probably finish up all the other little details of that one, right? Okay, we'll have to finish this up last time since we spent so much time on our encryption activity. I'm not sure if it was worth our time or not, but
12:38.